In the previous video, we learned about the researchers' effort to sharing out the carbon dioxide burden. In this video, we will take a look at what genetic changes are responsible for the evolution of phenotypic traits. So, let's start with the video. Science refers to convergent evolution, which occurs when animal and plant species independently develop features with the same shape and function. There are numerous examples. Fish, for example, have fins, as do whales, despite the fact that they are mammals. Birds and bats have wings, and many creatures from jellyfish to scorpions to insects have evolved the same weapons when it comes to using poisonous substances to defend themselves against attackers, the venomous sting. This research has 4 parts. First, identical traits despite the absence of a relationship. Scientists around the world are clearly interested in determining which changes in the genetic material of the respective species are responsible for the fact that identical characteristics have evolved in them despite the fact that they have no relationship. The search for this, according to plant psychologist Dr. Kenji Fukushima, is proving difficult. Such traits, we call them phenotypes, are always encoded in genome sequences, and changes in the genetic material can be the catalyst for the development of new traits. However, because the underlying mutations are largely random and neutral, genetic changes rarely result in phenotypic evolution. As a result, a massive number of mutations accumulate over the extreme time scales at which evolutionary processes occur, making detecting phenotypically significant changes extremely difficult. Number 2. A novel molecular evolution metric. Fukushima and his colleague Dr. David D. Pollock have now succeeded in developing a method that outperforms previous method in the search for the genetic basis of phenotypic traits. They created a new molecular evolution metric that accurately represents the rate of convergent evolution in protein coding DNA sequences. On an evolutionary time scale of hundreds of millions of years, this new method can reveal which genetic changes are associated with phenotype of the organism. It thus has the potential to broaden out understanding of how changes in DNA led to phenotypic innovations that give rise to a wide range of species. As a foundation, there is a massive data treasure trove. The fact that in recent years more and more genome sequences of many living organisms from a wide range of the species have been decoded and thus made available for analysis forms the foundation of Fukushima and Pollock's work. However, because many molecular changes are nearly neutral and have no effect on any threats, there is often a risk of false positive convergence when interpreting the data, which occurs when the result predict a correlation between a mutation and a specific threat that does not exist. Furthermore, methodological biases could be to blame for such false positive convergences. Number 4. Correlation spanning millions of years. To address this issue, they broadened their framework and created a new metric for measuring the error-adjusted convergences rate of protein evolution. This allows simulations and real-world examples to distinguish natural selection from genetic noise and phylogenetic errors. The approach, which has been enhanced with the heuristic algorithm, enables bidirectional searches for genotype phenotype associations even in lineages that have diverged over hundreds of millions of years. The two researchers examined over 20 million branch combinations in vertebrate genes to see how well the metrics they developed worked. They intend to apply this method to carnivorous plants as a next step. The goal is to discover the genetic basis for these plants' ability to attract, capture, and digest prey. Questions. When does science refer to convergent evolution? Genetic changes always result in phenotypic evolution. True or false? New methods can reveal which genetic changes are associated with phenotypes of organisms. Because many molecular changes are nearly neutral and have no effect on any traits, there is often a risk of what when interpreting the data. How many branch combinations were examined in vertebrate genes by the two researchers? I will wait for your answers in the comment box. Thank you so much for watching and supporting my efforts. Good luck and stay safe.